right, welcome back to Combining Functions Graphically. This is part 3, and albeit they're smudgy, but I have a function that is quadratic, that is f here, a little parabola, and we have this linear function which I've called g. And we're going to try and produce, without any algebraic help, we're going to try and see what kind of graph we have when we have f divided by g. And we know it falls into one of two categories. Either it's going to be a line with a hole, or it's going to be kind of a slant and vertical asymptote, which has curvy kind of graph results. So how do we know which is which? Well, let me show you a couple little tricks. One is, we could get a whole bunch of points. Like, let's say we start off with here at -3. Let's just go ahead and figure out what would the y value be of this combined function when I just look at the graph. Well, the y value for f is 0, right? We got this point here at -3, 0. So we're going to have 0 divided by, and the y value for g looks like it's -4. So that's just going to be 0. So that point actually isn't even going to move. It's an invariant point. So we're going to have -3, 0 as one point on the graph. Let's have another look at the next point. So there's one point. Then at -2, both graphs have the same y value, which looks like it's -3. So both y values are the same, and it looks like, aha, we're at the point -2, +1. Let's have a look at -1 and see what's happening. Function f has a y value of -4, and the y value of function g seems to be -2. So we are at +2. Let's throw in one more for good, actually maybe two more key points here. Let's throw in 0. Okay, so at 0, the y value of f is -3. And the y value of g is up here at -1. So it looks like we're getting +3. And finally, the last point we'll throw in is when x is 1. Now, both of these points have y values of 0. Sorry, both of these functions have y values of 0, which means, oh, I shouldn't have put that little bracket in there. There we go. What does 0 divided by 0? That's actually undefined. Okay, so what do we have happening here? Well, look at these points. -3, 0, -2, 1, -1, 2, 0, 3. They keep going up by the same amount. This is a typical linear relation. Every time we increase the x by 1, it happens that we're going up by the same quantity each time, except when we get to here where it seems nothing is there's no actual point. So what we have here, so I'll just clear this, and we're going to graph these points now. What we have here are the following points: -3, 0, -2, 1, -1, 2, 0, 3, and then at this location we have a hole in the graph. So here's what we have. It looks very linear. Okay, so if I connect all this to, whoopsie, uh-oh, let's see if I can fix that, do a neater job here. All right, it really wants to pull down. But anyway, there's the idea. It is going to be a line. Now, how do we know, what was the tip-off that this was going to be a line with a hole? Okay. The tip-off was, remember this point over here where both the quadratic graph went through this point, but so did the linear graph. They both shared a 0. So if they share a 0, this is kind of what we're expecting to see. Okay? So I think we have enough time to go and look at my last example. How do you spot when it is not one of these? So let's clear the screen, throw a grid up here, and let's see if I can draw a pretty neat graph here, so bear with me. So I'm going to draw exactly the same quadratic graph. So some key points with -3, 0, and -3, -2, -3, -1 I had down at -4, and then the rest should fit in pretty straightforward. So I'm going to try and do as neat a job I can on this. This side works reasonably well. It's this side here that gives me all the trouble. So we'll try and do it. Ooh, that's a neat one. Okay, one of my best ever. All right. Now, let's see if I can draw the line in there. Some key points on my line is I wanted it to go through here on the y-axis. I just want to keep it with a nice slope of 1. So let's see if I can draw that in okay. All right, start it down here maybe. And something like that. Okay, so I think we got a reasonable graph. We're going to call this F again, and we're going to call this the line down here. We're going to call that G. So let's look at some points using the same strategy as before. Now, I'll tell you right away. Here's the key. While I have a good picture, use it and show you. They don't share any of the x-intercepts. Okay, both graphs have different zeros. Now that tells me right away it's not going to be a line. How do I get a reasonable graph of this thing? Okay, well, we're going to get a bunch of points to do it. So -3, for the same reasons as in the other one, I have 0 for the y here, and I have -2, 4, 5. So this is going to be a y value of 0. Then let's have a look at -2. So it looks like a y value of -3. And then for my line, it looks like a y value of -4. So it looks like something like positive 0.75. And then let's take a look at -1. We have a y value of -4 and a y value of -3. Like they're switching it up here. So 1.3 repeating. And then at 0, we have -3 divided by -2. Okay, so I'm just plugging in those y values and getting some points. And then at 1, this time, we just have 0 divided by -1. So that's just going to be 0. Okay. And at 2, so I'm going to throw in one more here. We have some kind of, I'm not even sure what it would be here on the f function. Let's just say it's, I don't know, some big number, some big positive number. But look at what I'm trying to divide by. I'm trying to divide by 0. So this is going to be an undefined. Okay. And then the only thing I'm going to say after that, I'm not going to go on and on with points, but anything that's greater than 2. Okay, if I look at these, both functions are positive. So I'm going to have some big positive y value for f and some positive y value for g. So I know I'm going to get positive results. Okay, that's the important thing to notice there. So now let's clear this off, put a grid up, and try and get a picture. So picture might look something like this. We've got -3, 0. Then we've got -2 goes up 3/4, so roughly there. -1 went up 1.3, so it looks almost linear here. 0 goes up to 1.5, but here's where it's, it's not really behaving very linear anymore. Then we got 1, 0. 2 is undefined, so we kind of leave that for the moment. And then after that, we know it's always positive. So clearly what we see is non-linear. Question is, how do we sketch a graph? Well, that tells us that here, where it was undefined, that's going to be a vertical asymptote. Okay, so that much we have. And then it looks like we're expecting a slant asymptote somewhere to be happening. I'm not exactly sure where, but remember, we're just trying to get an approximate picture going here. So it's probably running along here somewhere, because this part looks like it's bending down to there. And if I had enough of the original graph, I would thoroughly be expecting to see some section of graph up here somewhere doing something like that. Now that all depends if they provide you with an adequate amount on the original functions. And I don't think I had much going on over here. So this is just an educated guess. But this is the best we've got. So, summary. if you have two functions and they don't share any x-intercepts. Then you're expecting a non-linear, basically what we've got going on here. And you kind of sketch it the best you can. Remember, without the algebra, you're only providing the best picture you possibly can. It's not going to be perfection. All right, so things like where is the slant asymptote? Well, that would just be a guess. I'm thinking it kind of runs along like this. And then this one might have to bend a little more towards it. But it's just a guess. So this would be full marks, nothing wrong with this. So that's where I'm going to stop. Hopefully that has made things clear.